Cool. Welcome, everyone. I think we'll get started. So, this evening, as you may have seen on the newsletter and webinar, we're going to be talking about some of the new features that have been released in version 15.1, and kind of talk about what those features are and how you could potentially implement them and why they really exist. So, firstly, we're going to kind of we might go off in different tangents as we normally do. If you have questions about anything I talk about along the way, pop it in the chat and I'll be sure to pick up on it. I think we also do have the Q&A thing, but use the chat, it's easier. So firstly, I think the best thing to do would be jump on to the OCPP topic. So OCPP is the Open Charge Point Protocol. So this is the standardized protocol that different charging networks can adopt. So the use case of why Loxone may benefit from this is, let's say you have a restaurant which has got Loxone wall boxes, or you could have a car park or whatever, but a place where you have destination wall boxes that you've integrated with Loxone. Now, with the OCPP protocol, this enables easier billing. So up until this point, if you wanted to have public chargers, whether they're Loxone chargers or whether they're third party but controlled through Loxone, you would need to use perhaps have some sort of custom method, whether that's prepayment and then you give somebody an access card or an access code with the NFC code touch, you manually activate the wall box, and it's a bit cumbersome. So OCPP enables you to use charging networks like ChargePoint, for example. There's another one called eCarUp. Now, this enables you to use a charge card. So if you've got an electric vehicle through perhaps a business or as a company vehicle, or if you've bought an electric vehicle from a main dealer in recent years, you often get given a charge card. Now, this charge card then enables you to essentially have one contract and one payment method set up with one card. And instead of going to each charge point, setting up an app for each charge point, you just use one charge card, you hold it up against the RFID reader, and it just works. You can begin charging and then you're billed normally. And then it means the person who's hosting these public chargers can then get money from your charging session. So with that in mind, let's have a look at how this would be implemented within Loxone. So I'm just going to share my screen. So let's hit share. And we will go for this one. Okay, fantastic. So I head over into Loxone Config, and within Loxone Config, I've already prepared a couple of bits and pieces here and there. So what you'll see what I've already prepared is I've got like the wall box, a touch bill flex for a wall box, a meter tree. We're going to talk about climate control related stuff. So I've got an AC controller. But what you need to do to set up OCPP is very, very simple. So what I'm going to do is I'm going to go to Network Periphery. Now, you'll notice that I'm doing it Network Periphery. I'm not going anywhere near the wall box yet. And this is just for the simple reason that it doesn't actually have to be a Loxone wall box. You can just manage any wall box through Loxone and you take advantage of OCPP. Of course, I'd rather use the Loxone wall box because it's great. Now we go to add network device, and then you'll see here, now we have the OCPP server connector. This is still in beta because it's very early days, but it's fully functional and certified. But of course, there's going to be some learnings there. So you're more than welcome to use it. So I'm just going to click on it. Now we support two protocols. One of them is the version 1.6, which is the one that's more widely adopted. We also support the newer 2.0.1. Now, this is the future standard, but is not really being used as of yet. So, but we support both. So we go for 1.6 as a standard for now. Now, the thing you need to firstly is your server address. So I am using for this demonstration a backend, so a charge point protocol backend called eCarUp. Now, this is a free backend. You can host your own on like your own server, etc. But the other ones could be like ChargePoint. Now, with ChargePoint, it is a bit of an extensive process to get set up. But once it's set up, it's the most widely known platform out there. But eCarUp is quite easy to set up. It's got native integration with Stripe, so it's very, very easy. And so the first thing to do would be set up an account, and then we need to grab our server address. So here I've set up a free account. I've got an insecure address and a secure address. So I'm just going to copy this secure URL and go back into Loxone Config. And here I'm just going to paste my server address. And there we go. So once I've done this, you'll notice that when you add an OCPP server in config, it automatically adds one charging point. So I'm just going to press save in mini server for now. Now, the server connector will become active, you can see, so my server address is valid. But my charging point isn't because I haven't configured anything yet. And you can see I've got an error straight away because nothing's been done. Now, I say most, other charge point servers may give you a charge point ID. So you may need to set up the charge point like on their server backend first, like I was just showing you a moment ago. So it could be done here. In this case, I need to do it from the mini server, and then I set it up on the eCarUp platform. So with that in mind, I'm just, for this example, going to call it Loxone 1. So this could be just a random ID. If you want to authenticate, of course, you can. In this case, I don't need to. And then I could give this a charge point name. So we're going to call this webinar EV charger. There we go. And I'm just going to label this server connector as eCarUp. There we go. So now I save into the mini server. Once I save into the mini server, the charge point should then initialize, and I should get a green system status message. It can take a couple of minutes, but there you go. It's already gone green. So it's already initialized with my backend. So if I go back to my backend and I refresh, you can see already that charge point has become available. Now, this is a free backend, so I don't know what the reliability is behind it, etc. Of course, you need to do your own research depending on the scale of your network, but this is one example that I could easily get access to. Now, if I go to edit connector, this is where I can name it. So I'm going to call it webinar EV charger. I can give a description. I can define plug type, maximum power. So I've actually got a 7.4 kilowatt wall box at the moment. I can define my cost per kilowatt hour. So let's say, for example, we're going to say 35 pence. And if we wanted to charge a connection fee as well, we can. We can define access, so whether it's public, which can be used from all eCarUp and payment users, whether it's limited or private. You can start auto charging. You can do all sorts. So I'm just going to press save for now. And you can see as an overview, you can quite easily see what's going on. You can see the status to say that the charger is available. The reason why this information is necessary is so that you can be displayed on a charging map, etc. But that's kind of the basics of it. There's loads of details you can go into, which I'm not going to because it's eCarUp specific, but we'll focus on the Loxone side. So on the Loxone side, you can see we've got our eCarUp set up, the server address. We have our EV charger. Now, if we expand our EV charger, we have an API connector. So I'm going to drag this out onto the page because I'm going to use this just now. And I'm going to need a couple of devices. So of course, this is related to EV charging. And for EV charging, I'm going to need a wall box. So I'm going to drop my wall box onto the page. So now I've got my wall box. I can then add perhaps my meter. I can add my touch pure. I could add a touch pure flex, but in this case, I'm just going to add an NFC code touch. Let's go to NFC code touch. Done. And I'll drag and drop this onto the page. So then I can say that the first output goes to enable charging. and we could say the second output goes to eco. So I'm just going to do max 7.4 and eco charging or comfort and then eco. Let's say this is 3.4 kilowatt. And then we could say that this is 35 pence and this is 35 pence. Now, the reason why, one thing to point out here is the price per kilowatt hour. Anything I put in here into Loxone Config is only relevant to local users. So if I'm authenticating with my NFC tag on the NFC Code Touch as a local user, I am charged these prices because it then isn't sent off to the OCPP backend. If I go to, if I'm using a charge card, these prices are irrelevant. As soon as I use a charge card, it ignores these prices and uses what the OCPP backend defines. So I'm just going to press OK. So mode 1 is, sorry, I'm going to do the authorized charging does enable charging. Mode 1 is doing my eco charging, and mode 2 does max. This is just for basic authentication. Now, what I can do is this here is my EV charger from the OCPP server. All I need to do is drag this API connector and connect it to the Wallbox function block. This then establishes the connection to the physical wallbox. So things like energy consumption, etc., is done like so. But authentication for the billing is then done through this. So if I go to user ID needs to be connected to user ID of the wallbox from the NFC Code Touch, but also my API connector from the OCPP server needs to be connected. You'll notice when I said this, when I connect this, I get a message saying that OCPP is being used. The parameter AU is set to OCPP, and the setting duration on is set to 0.7 seconds. The reason why this is important is the RFID card that you get for like your charge card is RFID, not NFC. Now, these kind of come hand in hand, but traditionally the NFC Code Touch is restricted to just NFC. With the addition of OCPP, we now have the ability to use RFID as well. So the reason why we set authentication to 4 is so that it recognizes that we need to send the RFID value from the charge card to the OCPP server for the billing purposes. Otherwise, we wouldn't have the ability to do that. And now I save into the mini server, and that's it. So really, the configuration of my wallbox has maintained the same as usual. The only difference has been that I've connected my OCPP server to my wallbox. So now if I was to actually plug my car in my backend, I would see history. So you can see here when I was doing testing previously, you can see that I've got history. In this occasion, I haven't been actually charged anything because I didn't physically plug the car in. I was doing some simulation and I haven't set the account up properly. But you've got quite a lot of information here, which is then passed on to your account for payment information, etc. And then you would automatically get paid. Again, I'm not going to go into that, but you can see it's very easy to configure. And remember, you can connect any wallbox or any EV charger to the wallbox function block because of the inputs and the outputs. You aren't restricted to the Loxone wallbox, meaning you can deliver these sorts of solutions to existing EV chargers out there with the Loxone mini server. Okay, so as always, pop a message in the chat if you do have any questions at all as we go through. So now this kind of puts the wallbox aside. We can now move on to some other topics that we've got related to 15.1. So let's name this page a moment and just call this OCPP. I've said that word a lot, so I'm now going to move on and not say that again. So now we're going to move on to climate-related topics. So for climate-related topics, we have a few function block name changes for the reason that it makes makes the understanding of what that function block does a little bit easier. So with that in mind, we will just go through them now with one question. Can a single wall box be connected to multiple backends to as many payment platforms as possible? So I believe you may be able to. Let's double check. Let's add this connector. Can we connect it to multiple? It does look as though you can connect it to multiple. I think it's important to remember, though, that this is an open protocol. So whichever backend you choose to use should be universal across multiple multiple wall boxes and multiple platforms. So you shouldn't need to connect it to multiple backends. It's very rare that you go up to a public EV charger and you have the choice between ChargePoint or something else. It's one or the other. So usually I'll just stick to one. I think it is theoretically possible, but you want to avoid having dual transactions happening. So back to climate. With climate, you have a couple of function blocks, as I said, that have been renamed. So firstly, the climate controller. The climate controller has now been renamed to the heating and cooling controller. So you can see here that the heating and cooling controller comes up when I type in climate controller. But I also believe if I type in heat pump, you can see here the add function block for heating and cooling controller comes up. I believe the same may happen for boiler. Not quite boiler. Oops. I think I may have dropped out there. Hopefully not. So boiler doesn't work, but I know that some abbreviations, some names of sources will populate these function blocks. So if I add the climate controller, this function block in particular, the functionality still maintains the same. You just get a new name to help you understand, because all it's doing is controlling heating and cooling. What we can now do is touch over a couple of changes, not changes, but additions to the climate controller, or now the heating and cooling controller. So the heating and cooling controller, previously, you could use the outdoor temperature to influence whether we're restricting to only heating or only cooling, or maybe you can do both based on the average outdoor temperature over the last 48 hours. So otherwise known as weather compensation. Now, weather compensation can be done in so many different ways. And up until this point, as I said, we've been doing it over 48 hours. So the historical. But that's history. So why are we reacting to what's happened previously? This is still an option. And the outdoor temperature mode can now be adjusted from just off and on. So of course, you've got the mode 0. You've then got the average outdoor temperature for the past 48 hours. And you also have the expected 48 hours. So we have a new systems variable called expected average outdoor temperature 48 hours. The spelling mistake there. And this will give you what the average is for the next 48 hours. So your climate control system can react accordingly to what's happening in the future. And last but not least, you also have the option for current outdoor temperature. So whatever the outdoor temperature is now, this is what the system's going to respond by. And that's what we found works most effectively for our building, our UK headquarters, because the insulation isn't amazing. So what the outdoor temperature is heavily influences what the current indoor temperature is. But if it was a better insulated building or a newer building, it's going to operate a little bit differently. So that's why these options are now made available. We'll come back to this in just a moment when we look at some of the other function blocks which have been renamed, because we have a couple of changes to the visualization to make it easier to understand, particularly around the switch on threshold. So before we move on to that, we'll just look at some of the other function blocks that have been renamed. So the second one would be the intelligent temperature controller, which is now the flow temperature calculator, because that's exactly what it does. It calculates the flow temperature for your heating or cooling system. So what we can do, add that to the page. Again, exactly the same functionality as before. You only have a name change. There's nothing more to go through it. There's no additional changes to the functionality behind it. Another one being the AC control function block. So the AC control function block, which was brought out with the AC control air. So if I drag this out onto the page, you can see now this has become the AC unit controller. Literally just explaining it's your indoor unit. And that's what this function block is representing. So this is representing your flow temperature calculation. This is your heating or cooling controller, your heating or cooling source. And this is your indoor unit. So essentially making it black and white, exactly what these function blocks are designed for. And then before we move on to some further changes, we will just touch on a new function block, which is the AC central function, AC central controller. So the AC central controller is essentially like the heating and cooling controller. So like what formerly was the climate controller. The climate controller, we know, was initially there. One of the great features is to combine multiple intelligent room controllers, which are delivered by one source, which are the source of the heating or cooling is from one source, which is what the heating and cooling controller does. If I double click on that, you can see my intelligent room controller. Now, the AC central controller does exactly that for the AC unit controller. Here you go, AC unit controller. So now this enables you to group your AC units to one central controller. So this is representing your outdoor unit, your condenser. Now, why is this important? Previously, the AC unit controller, or the AC controller, is only looking at that room. So for example, one room could be calling for heat and one room could be calling for cooling. And they're both going to be sending what they want. But of course, some condensers can only do heating or they can do cooling. They can't do them simultaneously, depending on the brand. And this then enables it to talk to one another, similar to what the intelligent room controller does, and make sure that if one room's calling for heat, if there's a room calling for cooling, that room's paused until the room for heat is satisfied, and then we can call the other room. And that's what the AC central controller really enables. Now, one step further to that is the AC control air, when it was brought out about a year, 18 months ago, was designed to be a replacement of your traditional AC remote control or the wall controller that you would have. Now, after a year, 18 months of this being out, we've of course learned a lot. We've made a few changes to the software, and now we want to introduce the ability to automate your AC units with the AC control air and the AC unit controller. Now, previously, if you wanted to do this, it was involving lots of custom logic, perhaps status blocks in between, greater than, less than. So now it's as simple as ever, and very similar in the way that you'll notice now we have these reference outputs. Previously, we know that the intelligent room controller in the back end was linked to the heating and cooling controller. But now, just so you have that visual feedback, you can see here that I have a reference output showing me exactly where it's linked. Similar to if I had a couple of switch function blocks, I could connect this output to the input using a reference. If I click on one of them, it highlights the other. This is exactly the same for the climate function blocks now, so you can easily see how they're associated. And if they're on different pages, I could double click it and it would take me exactly to that function block. So with the AC unit controller, and we want to make this be automated, I'm just going to add a temperature sensor to my IRC. There we go. All I need to do is connect my API output of my intelligent room controller to the API output of my AC unit controller, like so. And now it links them together. Once they're linked together, the control of the AC unit is pretty much taken over by the intelligent room controller. So things like your set points, your current room temperature, etc., and your mode is dictated by the intelligent room controller. The only thing that then becomes adjustable from the AC unit controller is your fan speed and the louvre direction, so the airflow direction. Because of course, if you're in the room, you don't necessarily want it to disturb you, don't want too harsh of a fan speed, and that's what you can enable. The AC unit controller has also now got an input for your silent mode, which I can't find. Oh, there it is. It's the bottom. My mouse was covering it. So we've now got silent mode, and you could connect like the operating mode, night, to it, for example. So do I have night already done? Let's just add it. Like so. Drag this out as an input. So during night mode, your AC unit goes into silent mode, and you can define which fan speed silent mode really is, depending on your AC unit. It could be ultra low, could be low, etc. And this would ensure that you're not going to be disturbed during the night. Therefore, you don't need to specifically create some custom logic inputs and outputs on these function blocks because it's done automatically. Note that you do need an AC central controller for this to work, for them to talk to one another. So if I delete this for a moment and I try and connect my intelligent room controller to my AC unit, you can see here it's saying I need to have an AC central controller. So there we go, create new, and they've now been linked. So just keep that in mind, that it will prompt you to do that if you haven't already added one already. A couple of questions have come in the meantime. So how would you configure the inputs and outputs of the AC unit controller when using other interfaces like Intesis or Core Master Net? So the AC unit controller is primarily designed for use with the AC controller. It can be used with third parties like Intesis or Core Master, but it will require some additional outputs. The reason being is if we look at the different IDs and the different names of the outputs, we can change the description to what the customer understands, but the physical functionality behind it can't be changed. So to be able to replicate that same behavior, you would need status blocks, etc. For your specific use cases, Tomasz, we can look at them over on support, perhaps tomorrow or Friday, whenever is suitable for you. But it can be done. It just takes a little bit more logic. Same with everything. Like if you use the Loxone valve actuator or the AC control air, the Loxone touch, etc., it's much easier to configure. If you use a third party, I guess the configuration is somewhat similar in terms of like your inputs and outputs, like temperature and valve actuators, etc. If you're using relays or analog inputs, but your physical installation is much greater. So yeah, we can look at that in specific. And then another one from Bradley. So does the charge session automatically charge the card used on the NFC code touch after the session has ended? Correct, more or less. Basically, Loxone doesn't handle any of the billing. All we do is we are authenticating with a charge card. So you presenting your charge card to the NFC code touch. That's then sent over to the back end. The back end says, yes, this person can charge here, or no, this person can't charge here. And based on that, the charging session will begin. Once the charging session has finished, the information about the how much they've charged, how long they were connected, etc., is passed back to the back end, and the back end takes care of all the billing, so we don't get involved with it. Adrian asked, do you have to add users at the back end? Depending on the platform. So on eCarUp, I believe you can add users, but on on like other platforms like ChargePoint, I know it can be just on the go and on the fly. Basically, you don't need to manually add it. That's down to eCarUp. So whoever the manufacturer, oh, sorry, whoever the customer chooses to be their backend, whether it's ChargePoint because it's more widely known, it's the customer's responsibility to essentially have that working. It's very simple once it's configured. And this is one of the reasons why it's in beta still, so that there can still be some more wider understanding internationally around it, so that it's easier for you as Loxone partners to configure. Personally, because it's only just been released, I physically haven't set a live installation up with it yet. I just know how it's configured. But as we gain that experience, we'll be sure to make videos, etc., on it. Okay, so that is the renaming of function blocks, and it's the configuration of some of the new function blocks as well. One thing I will mention is, sorry, but what I'll do is I'll just change this to automatic mode, and I'm just going to save this into the mini server. And before we move on from climate control, I just want to show you the visualization. So if I open up the Loxone app, it'd be helpful if I go to the right mini server. Here we go. So if I go to here, you can see here as well with the wall box. This wall box is managed by eCarUp. So some things are hidden from the interface that you would normally see. Right, so if we go to not assigned, or perhaps not central, here we go. So here's our AC unit, AC central controller and our heating and cooling controller. So now you'll see in this user interface, we have the change that what used to be the climate controller gives you more information about what's going on. So if you have outdoor weather compensation, using the outdoor temperature to decide whether we're in heating or cooling mode, you can now see the digital thermometer and a comparison of what the current outdoor temperature is. Based on that information, it will show you whether you're in cooling only mode, heating only mode, or heating and cooling. But also on the right-hand side, you can see your threshold. So here we can see our 30% switch on threshold, which is traditionally set in your switch on threshold value within your heating and cooling controller or your AC central controller. This here is now displayed here in the user interface. So you can see that at the moment, my switch on threshold is set to 30%, and my value up to whether the heating is on is currently at 88% based on what the current temperature is in the room. So it's easy to understand and see here in the Loxone app. Now, if you want to see your traditional overview of your rooms, like the climate controller would always show you previously, we go to rooms, you can see just here. So you haven't lost the overview of your rooms, but this new improvement and an addition to the function block has been there to help people understand why their heating or their cooling may be running or why it may not be, but also why it may be only in heating or heating only mode or cooling only mode, and vice versa. So I think this is quite a nice welcomed addition. This is actually what you would have found on the on the HVAC controller, which was primarily made for the US market. But the heating and cooling controller and the AC central controller now has got this user interface. So it's much easier to understand. And whilst we're on the topic of climate control, you've now, on the intelligent room controller, we know that we've got the two temperature set points. So we've got our heating comfort temperature and we've got our cooling comfort temperature. Previously, back in the day, this used to only be one comfort temperature, which it would stick to, and there was a hysteresis and allowed deviation. And now this has been added back into the intelligent room controller. Just going to connect to my mini server again. So this has been added back to the intelligent room controller, and you can enable it by going to use single comfort temperature. So you can define what that single comfort temperature is. You can define your deviation, your eco mode, and also when you're using a single comfort temperature, what your offset is for excess heating or excess cooling if you've got your cheap or excess energy inputs used on your heating and cooling controller. So you have that ability now. Now, this may be beneficial in certain rooms where having that fluctuation may not work. We have it here in our office, where in the main open plan office space, it just makes sense to have one comfort temperature and not have that fluctuation between the two. Yes, it may mean you use more energy to try and keep and maintain that temperature, but in a workspace, it's kind of important. Comfort kind of overcomes other factors like energy consumption. So that's why we chose to use it here specifically. And that's a new addition. You can also enable and disable excess heating and cooling here as well for on a room by room basis, which is a new feature as well. Okay, so that pretty much covers the AC unit controller and the new function blocks relating to AC and climate control. With that in mind, let's move on now to, I think, what a lot of people are excited about is the new spot price optimizer support for 30-minute intervals in Great Britain. So if you've been living under a rock for the last 18 months, we released a spot price optimizer 18 months ago. And this enables you to take advantage of the spot price market for energy prices and energy tariffs. And this was only on an hourly basis. And we do have hourly spot pricing in the UK, but no energy provider at the moment utilizes it. There's one energy provider, being Octopus, which support 30-minute intervals with their agile tariff. Now, up until this point, if you wanted to integrate it with Loxone, it was quite cumbersome. You needed to use their API. It wasn't very straightforward, and it took a lot of logic. You also had to take into account things like daylight savings. It was a bit of a headache. Whereas now we have the change with the spot price optimizer, where you can take advantage of your 30-minute intervals straight from the European price exchange for energy. So if I go to create a new page and just call it spot price optimizer, the first step is, well, firstly, before we do that, I'm going to show you the documentation page. So we have a documentation page called spot price optimizer 30 minutes UK. So I've written this in quite a lot of detail to break down the exact steps to set it up. Although, yes, usually things should be simple, which it is much more simple like this. I thought it was valuable for you to be able to see it on a breakdown basis, but also I've recorded a 10-minute video, so it's shown here. But we'll go over it now as well. So to set it up, you need a spot price optimizer. So energy, spot price optimizer, add it to your page. Once you've added it to your page, over on the left-hand side, you have your mode. So you've got relative, absolute, and spot market. We want spot market. You've then got market area. We can then set this to Great Britain 30 minutes. And now we need to define our price calculation. So with that in mind, your price calculation, the way it's set up is your I1 is your wholesale price coming from EPEX. EPEX, the European price exchange for energy. Of course, you're not paying the wholesale price. I wish we were, but unfortunately not. So if I1 is our wholesale price, what's our formula to essentially see what our tariff is? Now, Agile's basic formula is the minimum price that the maximum price you'll always pay is 95, which is 95 pence per kilowatt hour. And this is actually £1 per kilowatt hour after VAT, which is 5% for electricity. And that's why they've set that formula to as it is there. D is the distribution costs. W is the wholesale price. So your distribution cost times the wholesale price. And then you've got your peak time premium. And now this will vary depending on where you are in the country and when you joined Octopus Agile. So what I'm going to show you now is how to do it on the easiest way for if you're a new customer. So the first thing to do is we need to grab the formula. Now, this formula that Octopus publish for their agile tariff, I've converted this into something that's for the Loxone formula function block. And this documentation page essentially explains what it means, which is why it's all in different colors. So I'm just going to copy this and paste it into the formula within Loxone Config. You'll notice now that we've also got support for min and max within the formula as well, because this here is exactly the same as the formula function block. This formula value here is exactly the same as what's in the spot price optimizer. So now that we've defined this, we now need to define our distribution costs, our multiplication factor, and also our peak time premium, so our D and P values. So to do this, you need to find out your region code. So this could be known as your region code, your DNO code, distribution network operator code. That's what DNO stands for. And to do this, it's quite easy to use Octopus's API for this, and you don't need any authentication. Anyone can do this. So I've linked it on the documentation page, and you need your postcode or your customer's postcode. So here I've got the example of the postcode for our office, and you can see my DNO code is H. Now, based on that, the DNO code of H is Southern England. So now that I know it's Southern England, I can go to the Agile Pricing Explained blog, which is where the formula is shown. I can scroll down to what is my D&P value. And you can see for Southern or South England, my distribution cost is 2.1, which is the multiplication factor, and my peak time premium is 12 pence. So my distribution costs go into I2 based on how I've done the formula. You should never need to change this formula unless Octopus change it themselves. So please, please, please make sure you use the one that's in our documentation page to save you the hassle. So I2, 2.1 for myself. It may be different to where you are. And I3 is 0.12. You'll notice that it says 12 here, and I've put 0.12, and that's to make sure I'm adding 12 pence, not 12 pounds per kilowatt hour, because otherwise it's going to get quite expensive. And last but not least, save into the mini server. And let's have a look at the Loxone app. Categories, energy, and here it isn't. Strange. Maybe that's because my mini server has no internet connection. That would be why. Oh, here we go. It's showing now. So the spot price optimizer is now showing me that right now, because it is 10 to 7, my price is very high, which is just shy of 30 pence per kilowatt hour. And as we get to 7 o'clock, the price is 12 pence less and even below that. Now you'll notice that I haven't got any information for earlier on today. And that's because the data is only pulled from now into the future. You'll also see as well that we may be missing some values for the future, and that's because the mini server hasn't pulled tomorrow's data yet. So the first day, some of the data might look a bit strange, but that's just because of how EPEX delivers the data to us. So we'll only show you the data from now until the end of today. And then within the next hour or so, it will show me the data from tomorrow. So for the data for tomorrow, we usually get published between 5 p.m. and around 7 p.m. If I go to next, you can see it's actually pulled the data as I've been talking there. So you can see tomorrow at, let's say, half midnight, it's going to be 9.5 pence per kilowatt hour for if I was on the Agile tariff in my location where I am at the moment. And the lowest is going to be 5.1 pence. I can show you an example of what today looked like. So if I go to our office, categories, energy, spot price optimizer, there we go. So you can see today, the lowest was 5.5 pence per kilowatt hour. And you can see a full-on graph of what today has looked like and also what tomorrow is going to look like as well in comparison. So really, really powerful what you can do here. Now, a quick overview of the spot price optimizer, like inputs and outputs. So I'm just going to show them all quickly. Now, these parameter inputs, the I2 and I3, are also available as inputs. So if the distribution costs and the peak time premium was variable and it changed over the year, then this is available. So if you have an API, you could then dynamically change this. Your period is so that, let's say I wanted in the next 12 hours, I wanted the cheapest 2 hours to turn my hot water on, for example. So I'd put my 2 hours in demand and 12 for the next 12 hours. So for the next 12 hours, find the cheapest 2 hours to turn my immersion heater on, for example, and it would do this. I could set this to half an hour, I could set this to 10 minutes if I wanted to, depending on how long the appliance needed to run. And these parameters can be adjusted in the Loxone app. Your trigger input basically starts that 12-hour cycle or whatever you define in that period, so that we can say, right, in the next 12 hours, find the cheapest period. And that's what that trigger does. That trigger also looks over that period and defines when the price is low, high, and very high. And the outputs are digital, so they'll become active. So let's say the price is currently very high, you could start load shedding, because if, let's say, your energy price is over 25 pence, you could start load shedding and turning things off that don't need to be on right now whilst the price is high. And you've got current price output, so you could connect this to an EV charger to see how much that's actually costing you to charge. So there's so much flexibility with the spot price optimizer. Question is there a way to incorporate standing charge so energy cost is taking into account that when displaying the cost of consumption / savings? So this here is, you can show your cost of grid consumption. You can't show because this isn't your agile export. Agile export, I'm going to look at what the formula is and whether we can use this spot price optimizer for that as well. I'm sure you can. I will just investigate it and then create a documentation page and a video for it. But at this point, it's only for import. And standing charge at the moment isn't available as like spot market. This is defined by your supplier and based on your tariff. So unless you have an API, you wouldn't be able to incorporate this. You could incorporate it through the inputs if you wanted to, but usually it's the same more or less every day, or at least for a fixed period of time. At the moment, it's not as dynamic as the spot price optimizer. This is only showing you for half-hourly intervals. It's not for the whole day. This is there to help you reduce your energy cost overall, and the 40, 50, 60 pence that your standing charges won't really make an overall difference. So it's not designed for that. But I'm sure possibly in the future you could look at it should it be necessary, but I wouldn't say it is right now. Okay, so spot price optimizer. That pretty much covers it. If you are interested in the details of it, as I said, I've created a documentation page which goes through it in quite a lot of detail. And there's also an example config on how to only heat during the 4 cheapest hours, etc. You can also see in the documentation of the spot price optimizer itself that how the calculation of very high, high, low, and very low is actually done. Cool. So let's close that and move on to the next thing. So a couple of things to talk about. Heating and cooling controller can use the 48-hour forecast. We've spoken about that. Now, these are just kind of informational now, which are just worth knowing, honorable mentions, I guess you could say. So we've always had the binary decoder function block, which I will show you just now. Oh, binary. So we've had the binary decoder, but now we have the binary encoder. So if you have binary inputs that you want to output an analog value up to 32 bits, you can, as it was previously just the decoder, which was taking an analog value and outputting a variable, outputting a binary output. We've now got kind of the opposite. So this could be useful for like Modbus if you're receiving, if you're using decimal value or binary values and you need to convert them to analog, or vice versa from Modbus, which is quite easy, and you then don't need to have loads of different custom logic. We have the dew point calculator. So if we go to the dew point calculator, so here you input your temperature and your humidity. So I'll just grab this from my touch for a moment. So this here could be used for calculating what your minimum cooling temperature, your flow temperature for cooling is. So you reduce condensation, etc. So this here is an example of the dew point calculator. So you don't then need to, again, create a formula, etc. You can also define an output offset as well, if necessary. We have a value validator. So the value validator allows you to set a minimum and a maximum value, and you can also define essentially what the output is over a period of time. So kind of what the meter function blocks have got to avoid any null values, you can now do this for an analog value. So whether this is something being read from I wouldn't say an unreliable sensor, but perhaps something that you want to, is always going to be within a certain range, and you want to make sure that what the value is that you're getting on the output is correct. This could be a great use case for this function block. What else do we have as new function blocks? So no new function block specifically. One more change to a function block would be the system schematic. So where is system schematic? System schematic, there it is. So the system schematic function block will now enable you to, if I add a image, let's see if I can add just a random picture. That's too big, great. Downloads. Have we got an image somewhere? Garden schematic. Here we go. Here's a random schematic I've got. So now I can add objects as you normally would, but you'll notice here we've got a grid, and you can do snap to grid, so you can have more nicely presented system schematics. You can add free to use text values. You can also do prefix for analog values. So let's say, for example, if I add let's add an analog value from an input. Here I could create some text which is displayed next to the value. So I could say temperature. And this here would then show in front of the analog value that I am displaying. So I could add a prefix essentially. And you can see that there's a snap to grid there to make it so that you aren't just throwing values all over the place. And I think arguably one of the best things, if I add a switch, one of the best things is now, let's add a switch, there we go. Let's put this on the page over here. Okay, it's save into the mini server. Now, anything that you have on a system schematic, to not assign system schematic, you can now see I can control objects from the system schematic, and I don't have to click into them to control them. I can do it directly from the system schematic, which is an absolute game changer. You could also, if you have like an icon, let's say I had a digital output here with an icon for a pump, it was green when it was on, red when it was off, you could have this dynamically change as well. And here you can see the text box that I added and didn't actually fill it out is blank, but you can also see that the 5.3 volts on my analog input has also got temp in front of it, just as an example. Nico, if you want to, can you change my analog input one? My demo case. Demo case over there. There you go. You can see now it's changed and that prefix has stayed the same. And there you go. Nico's now messing around with it. So that is a change to the system schematic, which is a real great addition to the system schematic. It kind of brings it more in line to the system schematics you can make in Exosphere. Now with Exosphere, it's of course more specific to bringing information from multiple mini servers onto one schematic, whereas this enables you to bring it to, also, of course, one mini server, but now have more control over it and make it look nicer, I suppose. Okay. Now, the last but not least is a couple of just informational bits. So if I'll stop sharing my screen for now, what's now great to know is the full system backup. So now your system backups up until this point have only been your mini server. If it was a client gateway, it would do all of your mini servers in the client gateway. But now it's also looking at all of your devices that could be backed up, like audio server and intercom. So if you're doing a backup of your mini server, it will also back up your audio server files and your and your intercom files within that backup. And that's also what Exosphere does. So if you do Exosphere backups, it's doing the whole system backup, which is great. Project planning, if you use the PWM, the single PWM channel, now instead of adding one RGBW dimmer per channel, if you were doing it across rooms, it now allows you to share one RGBW dimmer across 4 rooms, for example, as long as you're using the RGBW tree that sits in the panel rather than the compact one or an air one. So if you're using compact or air, it will just do one per room. If you're using the dinner mounted tree, you can then share it across, which helps for planning projects a little bit easier. And then finally, EE bus. So Valent and Loxone have the ability to communicate in quite a great way using EE bus, allowing you to define zone temperatures, monitor various different values from the heat pump or boiler or heating system in general, and then also control it. They have this internet gateway, previously the VR920, the VR921, and now the VR940. As Valent updated this internet gateway and also introduced new firmwares, it meant that you could no longer use EE bus integration. They've now updated it again. We've changed the firmware, so now you can now integrate with the new Valent interfaces, which also allows for power monitoring. So if you have a heat pump with this internet gateway from Valent, you can also monitor the electrical power consumption, not the heat or cooling power consumption, but your electrical power consumption of the heat pump, and bring this into MeterBox within Loxone, which is also really great. That's pretty much it for what's new on 15.1.